Hello friends, in this video we are going to discuss about a numerical on junction field effect transistor. The numerical looks like this. A diagram has been given, and in the diagram we can see there is two region P plus and P plus, and there is another one in between is N region. So actually this is the side view of the junction field effect transistor. So we can write this is the side view of JFET, where these are the two highly doped region P plus, and in between there is the channel which is N type. That means this is a N channel JFET. Now in between this it is given that the width of the P plus region is 25 micrometer and the width of the channel is 50 micrometer. Now we can define that, and we also know that this P plus region will produce a depletion layer, and the depletion layer can look like this. If this is the, so this will be the depletion layer, and the width of the depletion layer has been given. So let us denoting it as W dash. So this is W dash, and this is also W dash, and W dash is given by 0.25 micrometer, and the doping concentration of the N channel is 10 to the power 20 per cc, and the mobility of the electron in the channel is 1500 centimeter square per volt second. Then we have to find the value of drain to source resistance. So now we can say that this is the actual width of the channel before the depletion region has been formed. So we can say that this is nothing but the 2A. So 2A is nothing but the 2 micrometer. Now we can find the value of 2B, and this 2B is nothing but 2A minus 2W. So 2B is nothing but the dip channel width near the this terminal. So 2B can be given as 2A minus 2W, and 2A is given by 2 micrometer, and 2W dash, and W dash is given by 0.25 micrometer. So we can find this, that it will be 1.5 micrometer. So 2B can be found in this way, and we know that the channel drain resistance, that is the drain to source resistance, RDS, is given by capital L divided by 2BW Q ND into mu n, and we can see that every value has been given, and using these values of L is 50 micrometer, B is given, W is given, Q is given, ND is also given, mu n is also given. So if we put all the values, then we will get 0.139 micrometer. So this is the value of the channel drain to source resistance of the N channel JFET that is given inside the problem. Thank you.